According to UN Environment Programme, corals will experience a 70 to 90% decrease by 2050 if nothing is done about it. Our solution? Corallius, the semi-autonomous underwater drone made for coral restoration. So, why focus on corals? Well, corals are the providers of food, shelter and oxygen to marine life, in addition to being protectors of coastlines from storms and erosion. However, according to NOAA, 83.9% of the world's coral reef areas are experiencing bleaching level heat stress. Among those areas is Condal Island, Vietnam, Rio de Fogo, Brazil, and one that hits particularly close to home, Pulau Bidung, Terengganu, Malaysia. So why not just send out divers then? Why use Corallius? Well, in 2018 alone, 189 divers lost their lives, while 2,069 divers met injuries in their adventures. With the use of Corallius, we can significantly reduce these numbers. We have two main goals. The first, aligning with UN SDG 13, climate action, is to reduce the impact caused by global warming through the restoration of coral reefs globally. This is because corals produce 50% of the world's oxygen while absorbing nearly 1/3 of the world's carbon dioxide. Our second goal aligns with UN SDG 14, Life Below Water, as we intend to improve marine livelihood through data collection to better understand the causes and methods to mitigate the effects of coral bleaching. We are Nemo Inc., a dynamic team from Asia Pacific University, Malaysia, merging our expertise in engineering, programming, robotics, and web design to create the key in unlocking a more sustainable future. This is Christabel, an expert in all things money related and leads the marketing aspect of Corallius. Next, we have Shen Yi, someone who is not only designing our websites and drones, but also our future as well. Following that, we have Ritikesh, our fearless leader who not only holds the group together, but also motivates us through his never-ending optimism. Last but certainly not least, hi, I'm Ang Yen, a robotics enthusiast who, more often than not, would much rather spend time with robots than my own teammates.
So now we're going to talk about how Corallius works. The method Corallius is using to replant corals is a process called microfragmentation, where small fragments of corals are broken or cut from healthy parent colonies, and then they are secured to a suitable substrate. The fragments are then monitored in nurseries until they grow into larger colonies, and then they are brought in to be replanted into the ocean when they are ready. To support coral restoration in its earliest and most delicate phase, Corallius uses a specially designed biodegradable mesh. It's made from natural materials like jute, cotton, and algae-based fibers, and this mesh gently holds the coral microfragments in place, helping them to stay anchored while they begin to grow. Over the course of 6 to 12 months, it safely breaks down in the ocean without harming the surrounding ecosystem. Its structure allows for sunlight and water to flow freely, encouraging healthy coral development. Since it's completely non-toxic and free from synthetic chemicals, it poses no threat to marine animals, even if it's ingested. It's a simple, eco-friendly solution that helps to give coral reefs a strong start. Then the secured coral fragments are brought into a boat in bulk, and then they are arranged on a deployable platform, and this platform is attached to the boat. When Corallius is ready to start replanting, the platform is lowered into the ocean like this, and Corallius can access the coral microfragments arranged on the platform. After that, Corallius will retrieve the fragments from the platform, plant it, and then return to the platform to retrieve the next fragment. And this cycle is going to repeat until all the coral fragments have been planted. And now this is the diagram and 3D model of the architecture of Corallius. So the body of the drone is shaped to be hydrodynamically angled to help reduce water resistance. And these are the underwater propellers that serve as the movement system for Corallius. These propellers are protected by this hexagonal propeller guard, and it comes with mesh covers, and this will help to shield the propellers. It will help to shield the spinning blades to prevent damage to marine life. And the robotic claw here is what's responsible for the coral implantation process. The claw is attached to a retractable tether line, as you can see here, and this whole claw system is attached to Corallius via these reinforced mounts. So now onto the materials used to make Corallius. The drone body and the underwater propellers are made out of anodized aluminium, and then the robotic claw is made out of titanium alloy, while the actuation links are made out of stainless steel. The propeller guards are made out of marine-grade reinforced plastic, and there's protective padding on the robotic claws that are made out of soft silicone rubber. These materials help to ensure the drone is lightweight but still strong, while also being non-corrosive and wear-resistant to help enhance its durability, especially underwater. The materials used are also cost-effective without compromising quality. And lastly, they are ensured to be non-toxic so that it won't affect the marine life in the long run. And lastly, here is a working prototype of the robotic claw of Corallius.
Moving forward, I'll be talking about the product showcase, which is used to carry out precise restoration work. Corallius relies on waterproof and shielded communication cable that also delivers power from the surface. This means it can operate for long periods without the need for internal battery swaps. Passive sonar sensors help it detect nearby objects and marine life by picking up natural underwater sounds, allowing it to navigate safely without causing harm. Corallius is also equipped with environmental sensors that monitors water quality including pH, turbidity which is important for ecotourism zones, temperature, heavy metals as well as microplastics. If conditions aren't met, planting can be paused to protect the coral, and in case of emergencies like a leak, loss of signal or critical system error, a built-in airbag deploys to bring the drone gently back to the surface, ensuring both safety and data recovery. Moving forward, I'll be talking about the data collection. Corallius doesn't just plant corals, it helps monitor and protect it. With a 360-degree camera on board, it captures clear, detailed visuals of every restoration site, aiding in coral species recognition and early detection of diseases. This helps researchers and conservationists make faster, more informed decisions. This data collected images, water readings, and environmental logs is stored and uploaded in real time. By sharing this information with restoration partners such as Reef Check Malaysia, Coral Co, Bajut, we ensure that every deployment contributes not only to reef regrowth but also to a deeper understanding of how to restore marine ecosystems better and faster. It's coral restoration with impact, designed for real-world challenges.
Now let's take a look at the market analysis. We will do SWOT analysis to identify the key strengths, weaknesses, opportunities, and threats. Coral reefs are critically endangered and restoration efforts are traditionally slow, labor-intensive, and limited to shallow water. Our solution changes that. Corallius, a semi-autonomous drone to facilitate coral restoration. Corallius reduces main power needs, automates repetitive coral planting tasks, and is capable of operating in deeper, more dangerous marine zones where divers can't easily reach. It meets the growing demand of sustainable tech and ecotourism, offering a long-term environmental and economic benefits. To strengthen our mission, we are going to collaborate with Coral Catch, a non-profit organization dedicated to marine conservation and reef restoration. Because challenges remains, our solution includes high initial research and design costs and comes with a significant technical complexity. We must also navigate unpredictable ocean conditions, adhere to marine regulation, and make sure that we minimize any negative impact on marine wildlife. Now that we have outlined the key strengths, risks, and opportunities, let's take a look from the financial perspective. With an upfront cost of 10,000 to 15,000 ringgit and expected yearly revenue of 25,000 to 60,000 ringgit, we are looking at a solid 150% to 240% return on investment, with payback possible within just 2 years. To support our mission and ensure long-term impact, we have built a diversified and sustainable set of revenue streams. We bring the ocean to viewers in real time through our 24/7 underwater live streams on YouTube and other platforms, generating income via ads, sponsorships, and fan donation. Our underwater footage is also captured and sold as high-quality stock images and videos, catering to educational platforms and media outlets. For those seeking a deeper connection, we offer subscription-based services that provides exclusive content. By becoming a Corallius subscriber, members enjoy a completely ad-free experience on our official website, making ocean exploration seamless and uninterrupted. Each subscriber receives one free redemption code for our signature Nemo activity, along with a 30% discount on future coral naming purchases. Members also enjoy 50% off of all official Corallius merchandise and stock images purchases. Most importantly, every subscription directly supports coral restoration effort right here in Malaysia, making every benefit a step toward a healthier ocean. Through our Nemo Coral initiative, we invite supporters to take part in the mission. Supporters in Nemo Coral fragment they help restore, offering a personal and meaningful way to engage with the cause. Lastly, our branded merchandise not only raises funds but also spread awareness. Together, these streams create both financial sustainability and passionate community around reef restoration.
Why we are the next generation of innovators? Because we refuse to inherit a dying ocean. While the world debates solutions, we are building them. Not tomorrow, not one day, but now. Where coral reefs are fading into memory, we see the blueprint for revival. Where others see risk, we see responsibility. We are not just students, we are engineers of hope, biologists of change, designers of the future. We took metal, data, and light and turned it into a life-giving purpose beneath the waves. Corallius isn't just a machine, it's a message that this generation doesn't wait for the world to be fixed.